right, good afternoon. My name is Peyton Kara,
And my name is Karla.
and this was our SWOT analysis. So let's just go ahead and get started with the strengths and weaknesses for myself. Some of the strengths that I found in my paper was the incorporation of different data types. So examples being continuous and discrete. It had multiple different safety experiments, right? Method comparison and some pathogen prevalence. It also was mentioned. It also mentions It had a good source of practice by the authors. The authors were very transparent, and they also acknowledged their own weaknesses during their own research, which kind of goes into the weaknesses section for myself. The paper had a lack of handling for non-detectable values and negative values. The paper mentions limits and quantification, right? Especially if the value falls below what we really are looking for, and just a lack of general missing data. This can show up in places like the USDA and FDA archives. I know for myself, these archives, big archives like this, they get very mucked up once more and more stuff gets added to it. But some opportunities that I found while reading the paper was good collaboration with companies that are willing to test their product. This is always a great thing to have when you're testing these things. Access to consumer relevant data would have been a good opportunity to really go into this paper, and teaming up with experts in the microbiology field would have been a good opportunity too. Um, I know as us computer science majors, we don't know I mean, we're not nutrition experts, but microbiology experts would be able to help us remedy this. Some big threats that were in the paper were the complexity, again, of microbiology. This can impact the effectiveness of the research. Given the types of stores, small and medium stores, really like mom and pop type stores, they can have resource limitations that could negatively impact the research. And while this paper was published in 2024, food safety is a constantly evolving phenomenon. For example, there's the food pyramid back in 2005, but it changed in 2011 to something different, which had less information on it. So it's just this thing is a constantly evolving phenomenon. But let me go ahead and pass it off to Gaurav to talk about his strengths and weaknesses.
Okay, the paper that I reviewed was on increasing the national nutrition data system to promote diet sustainability analysis. Okay, I would like to highlight some of the key strengths and weaknesses of our data platform, as well as some of the opportunities and threats. Starting with the strengths, my platform, like detailed ingredient breakdown, really sets it apart by deconstructing complex food into basic commodities. We provide a foundation that supports a broad range of studies, be it on the environmental, economic, or social aspect of diet. The platform versatility also allows researchers across disciplines to standardize dietary data, which is essential for cross-disciplinary studies, especially in the nutrition. Also, it is established utility in assessing diet-related health and environmental impacts, along with the frequent updates, keeps it responsive to the latest information. However, there are some notable challenges, like the complexity of our database structure makes it tough for non-experts to navigate, potentially limiting its accessibility. The platform dependencies on other databases can also impact the results, and the current data sets lacks information on the social impacts such as food equity. And looking into the opportunities, here, like collaborating with agencies like EPA, USDA could secure funding to support more regular updates, which could help boost accuracy and relevance. Additionally, expanding the research capacity by adding data sets on diet sustainability, new food commodities, and consumer behavior could open new areas for study. And along with that, integrating with other imaging databases could further enhance the platform reach. On the other side, the threat that can come here is regular updates are essential to avoid obsolescence, especially newer data sets and AI tool come into the scene, offering fast, more advanced analysis of food sustainability. So high maintenance costs are also a big concern, and outdated data risks leading to the inaccurate conclusions. And in summary, this has all the solid foundations on exciting potentials. And let's come to the collaboration and discussion that we got out from these two papers, Perin and me. Uh, in both the papers, they offer a strong advantage by using detailed data types, enabling us to analyze health risks and environmental impacts more effectively, which enhances in the real world applications. However, handling missing data remains a challenge and it can impact accuracy. So collaborating with external databases and companies that are willing to test uh, could help bridge these gaps. Additionally, the complexity in the data analysis can limit accessibility for non-experts. So for that, also working with experienced researchers and simplifying the data formats could make the insights more adaptable and user-friendly. Finally, both datasets face a risk of outdated information impacting accuracy. So regular updates and resource allocations in this area could be a key to maintain reliability.
Right, well said.
So
So, ooh. But using our strengths here, we can use our extensive ranges of data types in order to run more complex experiments with insights to food safety. We'll be able to apply a standardized good dietary data just from across multiple different fields, and we'll be able to leverage the current health system's good successes as a foundation for us, right, to expand our more recent emergent areas of sustainability, which will lead us to addressing what our weaknesses are coming into this. We will be able to use these frequent updates as well as collaborations with other companies to remedy any values or really lack thereof that could disrupt our data set. We'd be able to employ different safety checks as well as specific food categories, which would help really minimize the lack of food equity. We could gradually build up our own data sets, which would help us really get off of bad, poor data sets made by like the FDA, and we could rely on our own good databases. And going back to food equity, surveys are always a good thing to have when dealing with this kind of stuff because we got to get user input for this kind of thing, which is our actionable steps to threats and what our opportunities are. So our opportunities, we could pursue companies that are willing to test their product as well as collaborate with other microbiology experts. We can gain more insights into better diets. We can start integrating new and emerging data sets, which this would eliminate chances to get poor data. We could just constantly have new and evolving data currently going into our data sets. But some threats that we'd be able to mitigate is outdated data, big problem. But we can handle this if we implement a good schedule of constant database updates. And any misleading conclusions would come about just due to different employers, but we could fix this by just making sure that who we're talking to is consistent and they're giving us consistent data. But this would lead us right into our conclusion.
okay, in conclusion, both datasets are very impressive in their breakdown of detailed information and in their showcasing practical applications, especially in the health and environmental research. While they face challenges with complex analysis and machine data, this can be mitigated by collaborating with professionals and partnering with the other big organizations. Lastly, but not the least, the risks of outdated data leading to inaccurate conclusions underscores the importance of frequent updates, and better resource allocations to ensure data accuracy and reliability. Thank you.
Thank you very much.